Now, once we start getting to the idea of having fractional squares, finding the area actually um, becomes a lot more complex because we have a lot more options. So when you have just whole unit squares, it's very easy because you're stuck to using whole numbers. But now we're getting into trying to create rectangles that have perimeters that are fractions. So I know that each of these squares are a quarter by quarter. So I know that if I go 2 squares, that's like a half. 4 squares would be like 1. So if I'm trying to make 9 centimeters total, if I do 1 here, I know that I'll end up with 1 on the opposite side, which means then there's 2, and then that would mean my other 2 sides then would have to add up to 7, and I know 7 divided by 2 would be, each of those sides have to be 3.5. So let's just we're going to find the lengths of each of these sides. So here the perimeter is only 6. And part of that is because I didn't get my sides long enough, right? So I'm going to delete, move this out of the way. So I need to make side DC. I need to stretch down D and C. So if I stretch it down here, now I've got 2 3/4, 2 3/4, but now I'm only up to 7.5 perimeter, so I got to keep going. 8.5. And there I now have a perimeter of 9. Now look at my side lengths. 2 sides are 1 centimeter, the other 2 sides are 3.5 centimeters. So it's not those easy whole numbers anymore, especially with my perimeter of being 9 centimeters. Let's get that out of there. Alright, so that's one option. And this is how it's going to be for a lot of them. So sometimes it may be easier just to lay out a rectangle and then to start to manipulate it based on knowing the side lengths and the perimeter. So I know this is 2.25. So I can think about each of these. So if I find the perimeter, I'm at 10.5. So I know, oh, I've gone too far. So maybe I need to change both these sides to 2. Oh, I'm at 10 now. So let me try raising this up. I'm at 9.5. Raise it up again, and no, there we go. These 2 sides, 2, 4, and then if I've got 4 there, I've got 5 left over to make up my perimeter, and 5 divided by 2 is 2.5. Okay, and I can also find the area if I wanted to. And just like the other ones, as my 2 values get closer, I can see that my area will continue to get closer to one another as well. So part of this is really just an opportunity to continue to play with creating the rectangles, recognizing that opposite sides have to be congruent and you're creating those 90-degree angles on the grid. It's just harder than the one with the 20 centimeters because we're no longer dealing with whole numbers, but now we deal with fractions. Now, if we wanted to create the greatest area from our rectangles, what we have always recognized before is that the closer the 2 side lengths are to one another, the greater the area. So if I make all 4 side lengths be the same value, then I get my greatest area. In essence, when I turn my rectangle into a square, because a square is a special rectangle. So to do that, if I think about it, that would be 9 divided by 4, and that would give me a side length of 2.25. So there's a half, here's 1, 1.5, 2.25. So 1 half, there's a half, 1, 1.5, 2.25. And if I'm slightly off, If I'm miscounted, it's okay, because again, I can click and drag. So I got my perimeter of 9. I can double check all my sides, so I can see that I do have the square. And I can verify it's my greatest area, seeing that's 5 and 600. So this is getting closer, but even by finding that single area, I do get a greater number than before. So the square still of my rectangle is going to give me my greatest area.